here is that we are currently learning about waves, and we need to learn what happens after two waves are headed toward one another. So let's pause the demonstration and discuss it first. Class, are waves objects?
No.
No, waves are a disturbance of a medium.
Waves are energy traveling through a medium, so no, waves are not objects.
Correct. Waves are not objects. So waves behave differently than objects. In other words, because waves are not objects, they can occupy the same space at the same time, which is why waves do not collide. Instead, when they occupy the same space, they interfere with one another via something called superposition. Let's watch what happens when the two waves interfere with one another. You can see that when the two wave pulses occupy the same space, the two wave pulses add together, and the resulting wave pulse is the addition of the original two. The general term for this interference of the two waves with one another is called superposition.
Superposition is the addition of waves when the waves interfere with one another. Got it.
The specific example shown here is called constructive interference because the two waves add up to a larger amplitude wave. And after the two wave pulses interfere with one another, the two waves continue on the spring with the same shape they had before. They continue on as if they had never occupied the same space and had never interfered with one another.
That makes sense because the wave pulse, which is stored energy in the medium, just continues on moving.
Wait a second. How do we know the waves do not bounce off of each other? It's not clear from the demonstration that they pass through each other and do not bounce off of each other instead.
Okay, Bobby, how about this as an example then? Does this help show that the two wave pulses do not bounce off of one another, but instead pass through one another?
Yeah, I can definitely see the wave pulses continue moving on after interfering via superposition. Thanks.
You are welcome, Bobby.
But this example cannot be constructive interference anymore, can it?
No, I bet this is called destructive interference.
Why?
In the previous constructive example, the two waves added to one another, constructing something bigger. In this example, the two waves seem to cancel one another out, and they no longer construct something bigger, but rather they seem to destroy each other. So I bet it's called destructive interference.
Well, you are correct. This is called destructive interference. But I do want to address one word you used, and the word is seem. You said the two waves seem to cancel one another out. They do not just seem to cancel one another out. The two waves interfere via superposition, and actually, while they occupy the same space, do cancel one another out almost completely. And you can see that they do almost completely cancel one another out when we pause the demonstration at the moment when the two waves occupy the same space. You can see we very nearly have what is called total destructive interference. If the two waves have the same shape and amplitude, but are on opposite sides of equilibrium, then we do get total destructive interference. The reality is that it is difficult to show a real example of total destructive interference because the two waves need to be perfect inverses of one another.
It's okay, Mr. P. I can see exactly what you were talking about. If it was total destructive interference, the spring would be completely straight while the two waves totally destructively interfere with one another, right?
Thanks, Billy, and yes, you are correct.